Chapter 21, Example 2. A county health department tries an experiment using several hundred volunteers who were planning to use the patch to help them quit smoking. The subjects were randomly divided into two groups. People in Group 1 were given the patch and attended a weekly discussion meeting with counselors and others trying to quit. People in Group 2 also used the patch but did not participate in counseling groups. After 6 months, 46 of 143 smokers in Group 1 and 30 of 151 smokers in Group 2 had successfully stopped smoking. Do these results suggest that such support groups could be an effective way to help people stop smoking? So now we're saying, do they suggest the support groups could be effective? So we're comparing the two. We're not saying what is the difference between them. We're saying, is there a difference between them? Which indicates we're going to do a hypothesis test. So we'll start with our hypothesis. Will be a little bit different than one proportion. We'll check our conditions. And we're going to use technology to do most of these calculations because of that pooling that you read about. It's just easier to use the technology. So first let's define. So let 1 represent Group 1, the group that receives additional support. So the group that gets that support group helping them out. Let 2 represent Group 2, the group without additional supports. So it probably makes sense that 1 is Group 1, 2 is Group 2, but just define the variables. Define those. It helps. So now we're going to state our hypothesis. The null will be that the proportion that quit with Group 1 minus proportion that quit in Group 2 equals 0. So we're saying there's no difference. That would indicate that the support doesn't help. The alternative is saying that there is a difference, that P1 minus P2 is greater than 0. We're saying that P1 has to be bigger than P2, so we get a value bigger than 0, which would indicate that the supports in Group 1 helped. So let's check our conditions. The subjects were randomly assigned to groups, and it is reasonable to assume the groups are independent of each other. The randomization helps with that. We have to assume that they aren't a husband and wife or siblings or something that live together. $143 and 151 smokers are both less than 10% of all smokers who try to quit. "46 of those in Group 1 had stopped smoking, 97 had not, both at least 10. "30 in Group 2 had stopped smoking, and 121 had not. Again, both at least 10. The conditions are met. I will use the normal model for a 2-proportion z-test. Now again, we're going to use the technology to do these calculations. There's no reason to ever do them by hand. Trust your technology. So we just want to write some statistics out, then I'll show you how to do it on the calculator. N1, our sample size for Group 1, was 143. And the sample size of Group 2, N2, was 151. Now we use the variable x to determine our successes, and that's what we'll need for putting it in the calculator. So x1 was 46, and x2, those that quit in group 2, was 30. That's all we need to do this with technology. Let's find one additional thing that we'll use to interpret a little bit, mainly from the normal curve. We'll find that difference. So P1 hat minus P2 hat equals 0.322 minus 0.199, which is 0.123. So now let's move to the handheld and work through this. So go to menu, blank document, menu, and as usual, statistics. Look right there, stats test, number 7. So we're going to pick a stats test. And we said we're going to do a 2 proportion z-test. Look at option number 6. It's a 2 proportion z-test. So we choose that option, and we're going to put in those statistics we just wrote down. Successes for x1 was 46. The sample size of group 1 was 143. Successes for group 2 was 30. And the sample size for group 2 was 151. So now we want to check our hypotheses. We said that P1 minus P2 is greater than 0. This gives us only P1, P2 on opposite sides. But if you move the P2, if you add it to the other side, you get P1 is greater than P2. So we want to pick the top option, that our proportion for group 1 is greater than the proportion of group 2. Click OK. There you go. There's all our statistics. The z-score and the p-value are the main things we're interested in. It went ahead and calculated that difference for us as well. That's the p hat there. But we're just worried about really that z-score of 2.40 and our p-value. So now let's look at the normal model with this real quick. 0 is our difference. We have a difference of 0.123 actually, so that's on the right hand side since it's positive. Over there we're going to shade to the right. That's what we're looking for. We want to find the area to the right. So if we were doing this by hand, we'd have to look at our table and do 1 minus the proportion we get. Our z-score was 2.41, and we had a p-value of 0.008. So now we're ready to state our conclusion. My p-value of 0.008 is very low, and I will reject the null hypothesis. There is evidence to suggest that support groups help smokers using a patch to quit smoking. So we have our conclusion there. We rejected the null. Now it's always a good idea to do a 95% or some sort of confidence interval to see where you think that real difference is. So we're going to go to the technology again. We'll go to statistics. This time we're going to do confidence intervals. And look at that, a 2 proportion z interval. We're going to put the exact same information in, and we'll just do it with a 95% confidence level like it's down there at the bottom. So we're going to do 46 and 143. We'll do our 30 and 151, hit OK, and there's everything you need printed out right there for you. You can see there the upper and lower is a confidence interval. So our 95% confidence interval will be 0.023 to 0.223. So I am 95% confident that support groups can improve the proportion of smokers who quit smoking by using a nicotine patch by between 2.3% and 22.3%.